Alright, in this video, I'm going to look at how we can use what we know about parallelograms to prove, starting with the definition of like a parallelogram or rectangle or so on, how we can prove various properties that we've already kind of seen seem to hold for all of these shapes, but we want to use the properties of parallelograms to prove them. Okay, so I'm going to give you, and it's not going to be a formal proof. I want to give you a very vague, sort of general idea of how we go about doing this proof. And now this problem, I would say I've deliberately not thought about it a whole lot beforehand, because I want you to see the thinking that I go through in order to get this, to figure this out. Okay, so the claim is that if a shape is a parallelogram, then its opposite sides are congruent. So here's a parallelogram, and what we want to say is the opposite sides are congruent. So let's start by labeling the whole thing, just so we have kind of know what we're talking about. So we're going to want to prove that, say, AD is congruent to BC. We could say AB is congruent to DC. It's going to be the same thing. Since it doesn't really matter which one we prove. If we prove one, then the same thing we would use the same rules or same steps to prove the other. So we'll start with trying to prove that. So let's say we're going to prove AD is congruent to BC. Okay. Well, let's look at what we got. We got a parallelogram. What do we know about parallelograms? Well, the definition of a parallelogram is that the opposite sides are parallel. So let's just mark that. These two sides are parallel, and these two sides are parallel. Please don't say four sides are parallel, because that would make no sense. All right, that'd be four lines in a row. Wouldn't be a shape. All right, we got opposite sides are parallel, opposite sides are parallel. So we got. Let's just write down what we know here. We got parallel lines. And what do we know about parallel lines? Well, the one thing that we've used over and over again that we talked about is these transversal rules. Just call them transversal rules, right? Like, the angles formed by the transversal and the parallel lines, it creates these pairs of angles that are congruent or supplementary. Okay, depending on which pair we're talking about. So that's probably going to be I want to have that in the back of my mind, that I know that. Okay. Another thing, well, we're trying to prove these two things are congruent. The only other thing we really know about that we've talked about with congruence is we've talked about triangles, right? Now, I don't expect that necessarily you would have thought of this just off the top of your head. That's fine. I've been doing this all the time. But again, I know triangles. I know something about triangles. I know rules for proving that triangles are congruent, right? I've got my SSS, SAS, etc. And I know that involves showing that two sides, the various sides are congruent, length segments, right? And I also know that if I know the two triangles are congruent, then I know that all the corresponding sides are congruent. So that might be connected. Seems like that could play a role here, except for the following obvious fact, which is that I've got no triangles here, right? So how could I make a triangle here? Well, we did some stuff with diagonals the other day, so think about that. Just draw diagonal. It doesn't actually matter which diagonal I draw. I'm going to draw this one. From D to B. That gives me two triangles. Okay, so this seems like this might be a useful piece of information. Okay. Well, now I've got two triangles. I've got ADB and CBD. Now, if I just look at those, it looks like those two triangles are congruent. It looks like, let's just say, I don't know how to prove this yet, but I'm just saying it looks like triangle ADB is congruent to ADB. That would go with CBD. Yeah, it looks like these angles out here are congruent. Well, I know this side is congruent to itself, DB. That's one we've used a lot. And maybe this angle down here and this angle. Okay, so I can see how that might work. How am I going to do this, though? And it looks like, well, we should see, look, if I could show that these two triangles are congruent, well, then the corresponding sides are all congruent, right? Because that's what congruent triangles mean. It means that every corresponding part is congruent. Well, that would mean that BC and AD would have to be congruent. Okay, so if I could show that, if I could show this, then I'd be home free, right? I'd have, say AD is congruent to BC. So if I could get here, That would be the thing, right? If I could do that. Okay, well, in order to do that, I'm going to need some. I've got one side, right? I know that DB, what do I got, right? I got DB is congruent to DB. I'm just putting stuff over here on the side that I know. DB is congruent to DB. That's reflexive. Reflexive property, right? Everything's congruent to itself. What else we got? Okay, well, go back to what we said at the beginning, right? I said, well, we know parallel lines, and we know the transversal rules. Okay, we know those transversal. So let's take a pair of parallel lines. We got these two, right? Okay, AB and DC are parallel. We've got some various transversals. We got BC. Okay, that's one. We've got AD, and that's another. And we've also got DB. I'm going to go with DB, and you can try all of them, but I want it for the sake of brevity. Try to just go straight to AB. So it helps often with these transversals to cut out the stuff that we don't need. So let's take AB and DC and the transversal DB, and I'm just going to redraw, kind of sketch them over here. So let's say this is A, B, D, C, and then I've got this transversal that cuts through them. Well, I look at my thing here, and I got, okay, well, yeah, this looks familiar. We did this a lot. Got a small angle here and a small angle here. So those two angles are congruent. If these two lines are parallel, then these two angles are congruent. Well, go back to our diagram. What does that mean? That means that this angle here and this angle here are congruent. Oh, so I can say, let's write down what we got here. We got angle, let's say ABD, go around the angle, is congruent to angle CDB, and that's, parallel lines. I'm just going to write parallel lines. Right, because I got those parallel lines. Okay. Okay, now what do I have? So now I've got this side here, got this angle. Now what are my theorems that involve angles and sides, right? We talked about the triangle congruence theorems. I've got angle, side, angle. I've got angle, angle, side. I've got side, angle, side. It could be any one of those. Which ones make sense? Because I'm going to need, either way, I'm going to need one more thing, right? I'm going to need one more congruent statement to get that the two triangles are congruent. Well, ASA would be angle, side, angle. So if I could show that these two, CBD and ADB, those are congruent. Well, it looks like it looks a lot like when I showed these two are congruent, doesn't it? I mean, it seems similar. The difference is this. What if I take another sketch, and I'll call this AD and BC, and again, I'm just going to leave out the stuff that I don't really care about, which in this case is DC and AB. Draw my transversal, which is the diagonal here. Okay, I've got parallel lines. I know all my small angles are congruent, all my big angles are congruent. Well, I got two small angles right here. Now those are congruent, right? These two lines are parallel. These two angles are congruent. What does that look like on the diagram up here? This is ADB, ADB, look, and CBD, CBD, right here. Okay, well, that's useful, right? ADB is congruent to angle CBD. It looks a lot like what we wrote before, but you can look closely, it's different. And again, that's just our parallel lines theorems. Well, what do we got now? We got angle, we got side, we got angle. Angle, side, angle, right? I'll mark this here. DB is congruent to itself. That's enough. So these three here, 1, 2, 3, are enough to show that these two triangles are congruent. If these two triangles are congruent, then all the parts that correspond to each other are congruent. And that includes AD over here, and BC. And those are my opposite sides. Let's sum up. Well, I know. So here's like my little, it's not a proof, it's kind of like, sometimes we call this a paragraph proof. This is even going to be less formal than a paragraph proof. But I've got, let's see. I'm going to write it like this. So we used, what theorem did we use? We used angle, side, angle. So I've got angle ABD is congruent to angle CDB. And that's because of parallel lines. I've got angle ADB is congruent to angle CBD. Again, parallel lines. And I've got DB is congruent to DB. I know it seems silly sometimes to say that, but let's be really complete, because what we want is someone to be able to look at this, go through this, and say, "Oh, now I can follow you. I follow you all the steps that you took." Okay. Then we can say, from those three, we can say triangle ADB is congruent to triangle CBD by angle side angle congruence theorem. And then we can conclude from that AD is congruent to BC. And we could say, because triangle ADB is congruent to triangle CBD. Right? And we've got our reasons. All we've done then is we've just started from the assumption that this is a parallelogram, so that the opposite sides are parallel. And we've gone through and we've shown that these two sides are congruent. We could also show, now, I guess just for the sake of completeness, we've got these two triangles. Well, these AB, side AB at the top here, also corresponds to side DC. So, for the same reason, we can say that AB is congruent to DC. So we've got both pairs of opposite sides are congruent. What you always assumed was that parallel lines, and we used these rules for about transversals, and we used our triangle congruence theorems, and we got proof that both the opposite sides are congruent. Now, what's the importance of this? Last thing here. What we saw in the exercise the other day with GeoGebra is that it looked like no matter what we did with the parallelogram, the opposite sides were congruent. Right? What we've shown here is definitively, conclusively, for real, that it has to be true anytime you have a parallelogram, you're going to have the opposite sides congruent. Okay? It follows from just the fact that the parallel lines, you have parallel lines opposite each other, from our transversal rules, which we've looked at a lot before, and from our triangle congruence theorems. All right.